Okay guys, this is just typical problem number 1, test 2.2. Of course, the most important thing you gotta do is make sure you know your kinematic equations. I've listed the 4 of them here in the x direction and in the y direction. Problem 1 says a cannon shoots horizontally. Keyword there is horizontally. So that means you go up here, it shoots it horizontally, which means it's going to come down like a projectile motion. Horizontally means what? That our initial velocity is 90 meters per second in the x direction and in the y direction, because acceleration in the x direction is 0. Y direction, what's my height? 90 meters up. Final velocity, final position is 0 because it's going to hit the ground. You know that your initial velocity is 0 because it's launched horizontally. In the y direction, initial velocity is 0. So first thing you always want to probably do is how to find the time. Plug in your numbers. I know that v naught t goes away right here, therefore I'm left with this. Solve for time. Time equals 4.29 seconds. Done. How much time until the cannonball hits the ground? That is also the amount of time it takes to go from here to here. That's the key thing you gotta remember. Problem number 2 is going to be pretty much the same thing. Problem number 2, pretty much the same setup. You have a height, pitiful drawing. It rolls a ball off a table. It has a horizontal speed of 1.6. The table is 1.2 high, so that tells you that my initial position in the y direction is 1.2 and 0. My speed is, let's see if we can do some highlighting here. My initial speed in the x direction is 1.6, final 1.6, y 1.2, negative 9.8. Once again, find that time. What makes these problems nice, that initial velocity is 0 in the y direction, so now it simply becomes a quadratic equation. Solve for the t. You should be able to do the math. T equals 0.49. Then you put that same time into the same equation in the x direction. You know this goes to 0 because acceleration, and then you get the final position is 0.784. That's how far it traveled. Here's a problem that looked complicated, but it's really not. Once again, you have a cannonball. It's launched at an angle of 36 degrees. Remember, whenever something's launched in that angle, you must find the x component and the y component of the velocity. Anytime you want to find the x component, you multiply by cosine. Anytime you want to find the y component, you multiply by sine. So my initial velocity is 120 times cosine 30, which gives me 103.92. It says, what is the x velocity of cannonball when it reaches its maximum height? Remember, at the maximum height, the y velocity is 0, but the cannonball velocity stays the same the whole time throughout the whole problem. Boom, 6 seconds. People forgetting, you gotta remember, whenever you see the word, whenever a problem starts from the same position, same level, and end at the same level, that's a half time. Let your problem cut in half. That way your VF in the y direction becomes 0. So what's cool about that is this problem's going straight up, no x stuff. How much time does it hit the ground? It would go up, come back down, and come back to the same level. Half time. I'm going to let my y naught be 0. My final position in this case is going to be the height, maximum height. We don't care. V naught is 28. My final velocity is 0 when you go straight up. My acceleration is negative 0.8 meters per second squared. T equals question mark. I'm going to use VF equals V naught plus AT, but I'm going to call this a half because I know that's halftime. Solve for T half, I get 2.86, got to double it, so my total time is 5.72 seconds. Halftime occurs when you start and end at the same level. If I'm shooting off a cliff, that's not halftime because I start high and end low. This problem was one of my favorite ones. It's the same thing, but you gotta think twice. There's two things moving. You have a cannon ball that's being shot, and you have a ship that's way over here that's coming left. And you gotta ask yourself, where does it have to start if it traveled at 12 meters per second to hit this at the same time where the cannonball is going to be? Once again, you have an angle. First thing we did was find our components. Since the ball starts at one level and end at the same level, I'll let this be a half time in the y direction. So that's why I came down here. I know his position was started in the y direction at 0. So I said, okay, let's let this guy, his initial velocity is 195.50. We know his acceleration is negative 9.8 t. His final velocity will be 0 at the top. So his half time is 19.52. His time will be 39.04. That time is the time it takes to go from here to here. So I can go back to the x direction, put into the first equation. I know xf is v naught times t, so I get my final position to be 62.81.5. Now let's talk about the ship. We want the ship final position to be at the same spot, 62.81.5. We don't know his initial position, that's what we're looking for. We know that he has to travel for the same time. This is negative because he's going what? Left. Plug all that in, boom, here's x naught is 67.50.0. Pretty interesting. Remember, everything that's moving has to have its own big 6 in the x direction, big 6 in the y direction. The ship did not have a big 6 in the y direction because he's only moving in the what? X direction. His initial position will be question mark. We know his final position is going to be 62.81.5. We know his initial velocity is negative 12. Negative because he's going left. You know his final velocity is negative 12 because it's the same. And you know his acceleration is 0. And you know his time must be the 39 seconds that you calculated in point 1. A little messy, but you got the point. Problem number 7. Rocket dropped from a 45-meter tower. Once again, shot. It's going to fall at the trajectory. Once again, this is not a halftime problem because it starts high and low. Y0 is 45. YF is, we don't know. Well, actually, we do know the YF. His YF has to be what? 0, right? Because he's going to hit the ground. His initial velocity is 0. Final velocity, we don't know. Negative 9.8 time. First equation again. This guy goes to 0. Solve for time, 3.03 seconds. Now we know this guy took 3.03 seconds to go from here to here because it's the same time up and down. Go to my x equation. I know my initial position is 0, final position is 30, my acceleration is 0, 32 is my final position. That should confirm that. I have 30, but for some reason I put 32 right here. That should have been 30. Put in the calculator. That's going to change that number a little bit. Let me take a moment and find my calculator. That turns out to be 2.8 0.84. I don't know if that's right. Let's check it out again real quick. Hand it in the calculator. We're going to take 30 divided by 3.03 and get 0.9. And let's try that one more time. That looks a little funny. 30 divided by 3.03 should be close to 10. Yeah, cooking with grease. V0 turned out to be 9.9. Cool. Meters per second, of course. If you begin to hear and listen, same thing keeps occurring. Ball thrown off a cliff. Car driven off a cliff. Bullet shot off a cliff. What is the magnitude of velocity when it hits the ground? Horizontal velocity is 25 meters per second. My initial position in the y direction is 10, final is 0, acceleration is negative 9.8. We do not have a time, so I know the only equation that doesn't have a time is the third one. So I plugged all my information in. Notice it's 0 minus 10. All that turned out to be a positive number, so when I take the square root I get 14. The one thing that people keep forgetting is that is the y component. How about the x component? Well, you know the x component was 25. You know the y had to be what? 14. So that's why you got to remember to find that resultant. This is the resultant right here, 0. Because when this thing actually comes in, give you a better drawing, when he hits the ground, he's coming in at an angle, right? So you got to use Pythagorean theorem. Be careful, just like on SAT, they will put that answer on there to make you choose that answer, thinking that's the correct answer. That is not correct. So whose theorem you got to use? Pythagorean theorem. Vx squared plus vy squared gives me my what? Final velocity. Square, square. Take the square root. I get 28. That's the magnitude. How do you find the direction? Direction is the angle, so it's the inverse of Vy over what? Vx. Because Vy is always on what? On the top. I get 29.25 degrees. Sophie solved, because it's going south of what side? East. Gotta remember, velocity is a vector, magnitude and direction. Okay, we have a target that's 3 meters from the building. The building is 10 meters tall. You have a ball that's launched horizontally, and it's going to land. Question is, how fast was it going when it left? V0 is our question mark. Just like the previous problems, you're finding what time. I use my YF. I know that V0 t is 0 because the initial velocity in the y direction is 0. Therefore, I can solve for time. Time is 1.43. X direction, 0 meters, 30 meters, acceleration 0. So now I know my final position is 3. My initial position is 0. In the x direction, I know this acceleration goes to 0. Solve for time. My initial velocity is 2.0 meters per second, not seconds. Reading graphs. You gotta remember, this is a velocity, this is a time. When you read a graph, this is 0. This and my velocity is 0. But when you shoot something up in the air, you know it has to be what? It's moving in the beginning. You know its final velocity is going to be 0. But you know in the beginning he's going to be moving. So let's call it 20 meters per second, something. His velocity is going from 20 to 0. So that means the velocity has to be going down. So on the graph, you want velocity to be going down. This velocity is 0 going up. Bad answer. This velocity is starting at some number, call it 20. it's going to go down to 0, and then it's going to go speed up but become negative. That makes sense, because if something goes up and it comes down, it's got to speed back up. This velocity is constant. If this was 20, the whole time it would be what? 20. Here, the velocity is what? 0, speeds up to 20, hits the brakes, slows back down to what? 0. This is called a velocity versus time graph. Number 12. A rifle is aimed at a bullseye. Let's let this be the bullseye. The rifle is aimed at that bullseye. Cool. Do you know when you shoot the bullet out the bullseye, it's going to actually drop a little bit, right? So the question is, how far below the bullseye would it drop? What direction is that? That's a what? Y direction. So let's call Y naught to be 0. I'm going to call my Y final, I don't know. My initial velocity is 0 because you shoot it what? Horizontally. Negative 9 meters per second squared is the acceleration. How fast is the bullet going? 320. How fast, how far away is it? 150. My speed is 320. I have so much information here that I'm going to use this to find my time, an x. I know that xf is equal to x naught plus v naught t plus 1/2 at squared. We know that the acceleration in the x direction is 0, so this goes away, right? So we're left with this equation. So now we plug in our numbers and get a time of 0.47. Now we know how far it takes to go from here to here and to drop from here to here. Go to the initial equation. YF equals Y naught plus V naught t plus 1/2 at squared, right? That's horrible. That's a plus sign right here, sorry. Anyway, in the y direction, you know the velocity is 0. You know the initial position is 0. So now we're left with just plugging in this one variable. I get a negative sign. That makes sense because why? It went below. If I call this 0, then it has to go down. That's why I said my final position is negative 1.8 meters, or you say 1.8 meters below the bullseye. Boom. This is doable. You just got to study. Good luck. Love you. Bless you.